this video, we are going to look at naming cycloalkanes. So, for example, let's assume we have a cycloalkane like this. How do you name this compound? So we need to first number the carbon atoms in the cyclic ring. So starting from here, this becomes 1, 2, 3, 4, 5, 6. And if we started from the reverse side, then here would have been 1, 2, 3, 4, 5, 6. So you see that the substituents are on carbon number 1 and carbon number 3 on both sides. Either you start from this this methyl group, or either you start from this methyl group. So the substituents are on carbon number 1 and carbon number 3. So we have 1,3-dimethyl. Then the parent name is a cyclic ring and it is 6. So cyclohexane. So what is the name of this compound? So it looks similar to the previous compound. So let's name it. However, in assigning the various numbers to the carbon groups in the parent chain, we need to start from the group, the substituent with the highest precedence. And you can see that this substituent is a sec-butyl and this is a methyl. Precedence is given to a sec-butyl over a methyl group, and therefore we start from carbon number 1, carbon number 2, carbon number 3, 4, 5, and 6. So at the end of the day, this is the sec-butyl is on carbon number 1. So we have 1 sec-butyl. Then there is a methyl group on carbon number 3. So 3-methyl. Then the parent chain is a cyclohexane. So cyclohexane. So now you see that on this compound we have 3 ethyl substituents. So we can start to label them. So this is 1, 2, 3, 4, 5, 6. So in this labeling that we did, the substituents are on carbon number 1, carbon number 3, and carbon number 4. We can also start from here. So this is 1, 2, 3, 4, 5. Pardon me, the first part, there is no 6 here since here was carbon number 1. And then the second part, 1, 2, 3, 4, 5. So the substituents are on carbon number 1, carbon number 2, and carbon number 4. Then we can also start from the reverse, that is starting from here. 1, 2, 3, 4, 5. And in that case too, the substituents are still 1, 2, 4. So you see that 1, 2, 4 gives us least number of carbons compared to 1, 3, 4. And therefore, the name of this cyclic alkane is 1, 2, 4. Then the ethyl groups are 3, so it becomes tri-ethyl. Then the parent chain, it is a cyclic ring of 5 carbons, so it is cyclopentane. So let's name these 2 cyclic compounds. In the first cyclic compound, the substituent is 1, 2, 3, 4 carbons, and the cyclic ring is made up of 6 carbons. So the number of carbons on the substituent is greater than the number of carbons on the cyclic ring. But in the second place, you see that this is made up of 1, 2, 3, 4, 5, 6 carbons. And then the cyclic ring is made up of 4 carbons. So the number of carbons on the cyclic ring is less than the number of carbons on the straight chain. Now, anytime you have an organic molecule, specifically an alkene, where the number of carbons on the cyclic ring is greater than the number of carbons on the straight chain alkene, then the parent chain becomes the cyclic ring. So you name it as a cyclic compound. Notwithstanding, if the number of carbons on the cyclic ring is less than the number of carbons on the straight chain, then you name the compound as a straight chain alkene, and then the cyclic ring becomes a substituent. So in this case, you see that there's 4 carbons in a straight chain, which is a butyl, and it is on carbon number 1. And then the ring is a 6-membered ring, and that is cyclohexane. And therefore, let me write the name here. The name of this compound is 1-butyl cyclohexane. But for this compound, you see that the cyclic ring is 4 compared to the straight chain, which is 6. And therefore, the cyclic ring becomes a substituent, and it is on carbon number 1. So that is 1-cyclobutyl. Then the straight chain is a 6-membered ring, so it is hexane. So these are the differences between a cyclic ring on a straight chain alkene. So let's name this organic compound. You see that this group here is an isopropyl group. So therefore, this becomes 1 and this becomes 2. So the name becomes 1-isopropyl. Then we have a 2-methyl. And the ring is 6-membered rings. So it becomes cyclohexane. So you see that we have a bromo group here. So we could have started numbering the carbons from 1, 2, 3, 4, 5, 6, 7. So a 7-membered ring. So the substituents are on carbon number 1, carbon number 3, and carbon number 4. We could also do the reverse, which is starting from here. So this becomes 1, 2, 3, 4, 5. The substituents are on carbon number 1, carbon number 2, and then carbon number. This is 1, 2, 3. Here's 4. Here's 5. Here's 6, and here's 7. So the substituents are on carbon number 1, carbon number 2, and carbon number 4. So you see that a 1,2,4 is better than a 1,3,4, and therefore we are going to choose a 1,2,4. So, and in naming, you see that this is a tert butyl, this is a methyl, and then this is a bromo group. So the bromo group alphabetically comes first, and therefore we will start with 4-bromo. And then after that, the tert butyl group comes second. So 1 tert butyl, and then the last thing is a methyl, 2-methyl. Then the cyclic ring is a 7-membered group, so it becomes a heptane, so cycloheptane. So let's name the following molecules. The thing to notice is that if more than one ring is attached to a straight chain alkene, then the parent name becomes the straight chain alkene. So even though the parent name may have number of carbons smaller than the number of carbons in the ring, if the rings are more than 1, then the parent chain becomes a straight chain alkene. So in this case, here's carbon number 1, carbon number 2, carbon number 3. So this is a propane. And we have a cyclohexyl group on carbon number 1 and carbon number 3. So this becomes a 1,3-dicyclohexyl propane. Now you can pause the video and then name this one. So you see that with this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. So we have a cyclohexyl group on carbon number 1. Then we have a cyclopropyl group on carbon number 2. So the name of this compound becomes, because a propyl comes first, a hexyl comes first before a propyl, then this becomes 1 cyclohexyl, then a propyl becomes 2 propyl, then the parent name is made up of 5 carbons, so that is a pentene. So the name is 1 cyclohexyl 2 propyl pentene.